Hi, my name is George, amateur call sign N2APB. I'm working here with Bobbie Williams for the University of Tennessee's Amateur Radio Club presentation of soldering demonstrations. I wanted to show first the basic tools that we'll be using throughout this demonstration. At the heart of it is a Weller WT-CPT temperature-controlled soldering station. It consists of this unit here and this soldering pencil, which controls the temperature of the tip. It's not turned down now, obviously, to 700 degrees, which I find is best for using for soldering circuit boards and electronic components. The temperature is controlled by means of an interchangeable tip, which is shown right here. This happens to be the I'm not sure of the exact number, TP7. The TP7 for the 700 temperature, 700 degrees Fahrenheit temperature of the tip. Controlled temperature is good because you don't want the temperature going down when you are connecting components, because the components will sink or pull heat from the tip. You want to create a constant temperature for soldering. So we'll show that here. Also, when soldering, you'll see me very often clean the tip just by going over here to this brass coil assembly in order to clean the solder off the tip and keep it nice and clean and bright and shiny with fresh solder. Doing so helps you really identify a good solder, identify a good solder joint. Some people, by the way, use in this type of a little area a wet sponge, which is okay to clean off the tip, but I prefer not to because that pulls temperature up and down off the tip and tends to wear it out a little bit sooner than it otherwise wears out. As explained in the slide deck, these soldering tips do indeed wear out and need to be replaced from time to time. The basic soldering tools, the basic tools used here on the bench for soldering are the needle nose pliers, edge cutters for nipping off the component leads when in the circuit board, stripping back wire, which will be one of the first things that we do in the demonstration. The solder, of course, is right here. I use 60-40, the percentage of tin to lead. 60-40 rosin core solder is very important because rosin helps clean the solder joint when you are attempting to solder two wires, two component leads together. When you are complete with the solder joint on an entire circuit board, for example, I like to go back and use a cotton swab with isopropyl alcohol. Just dip it in there and rub it on the circuit board and wipe it off with a cloth or a napkin. Removes any residue, natural residue, that is deposited by the rosin core solder. Otherwise, the solder is okay or the rosin is okay to remain on the board. It's nicer to clean it off, though. Checking junctions and other successful joints is a volt ohm meter. In this case here, I would put over to the ohms position and be able to measure a good connection. Lastly, what we're going to show here today at the very end is soldering or attaching components to a circuit board that happens to be an electronic keyer. It's called the NorCal keyer. You attach a paddle or an on-off key to the board, and out of the output comes a modulated Morse code representation of what you entered in on the iambic paddle, for example. And it has memories. It's a really cool little project. And we'll show parts of that, and if we're lucky, I'll be able to show the completed project at the end in operation. So there you have it. There's the basic setup of a good soldering station. Also note that I have a blue, this is an anti-static pad used for making sure that the soldering iron and all the components and myself on this soldering pad are all grounded. There's no static that would interfere with sensitive component parts. And it is connected to a ground over here by means of this clip lead, which is the same ground as the 3-prong ground for the soldering gun, for the soldering station, and the iron tip itself is grounded as well. So this is a good precaution to adhere to relative to making good anti-static, good connections with anti-static components. Off to the side, I have a fan, which is going to be gently blowing the solder fumes away from me and ultimately keep me safe. I've turned that on very low just to keep the noise level low here. So that's the basic setup. Let's get started. The first thing we're going to do is strip back some wire and show some basic techniques for connecting a wire such as this to a volume control or potentiometer, as shown here. We'll strip back about almost a quarter of an inch on each side, and note the polarity just of the wire, just with the mark. There's a wire mark on one side and there's no mark on the other. I meant to say a white mark on one side and no mark on the other. And after I twist the stranded pair together, we're going to take the soldering iron, which is hot. It's on. We're at 700 degrees Fahrenheit, and we're lightly going to tin the wires. Now this can be done in a fancy holding vise and so on, but over the years and with some experience, you'll get an opportunity to see that you can just kind of hold it separate right there. We'll lightly tin both sides. When I did that, I held the wire against the bottom of the soldering tip against the bottom of the wire, and I applied solder to the top of the wire. And I gently move the soldering tip up and along the wire to make sure that the solder was good throughout. So once again, I'm holding the tip up against the bottom of the wire and then applying solder to that hot wire at 700 degrees. So that's the first step for creating a wire like this, prepping a wire like this. What we're going to do is put a light bend in the wire in order to connect to the terminals of the volume control. With luck, they would fit through the holes in there. And as it turns out, this pot is the holes are too small for this wire, but that's okay. So what we're going to do instead is put the wire on along the side and just crimp it tight to it. And then I'm going to solder again, making sure I have a nice fresh dab of solder on the tip of the soldering iron. I'm going to come down and heat the opposite side of the connection that I'm applying solder to. So you see that I was applying it on the back side of that connector, and ultimately the connection is nice and tight, and solder is on that in a very good manner. In a moment, I'm going to show you a pour soldering joint by means of the color of the how shiny the surface is. So once again, I'm going to put the bent piece of wire around and just lightly crimp it to the terminal, as I have shown here, that middle terminal, which happens to be the wiper of the potentiometer. Clean my tip, apply fresh solder, and then on the back, I'll apply the tip, the hot tip, to the back of that connection while I apply solder to the front side. And this is to ensure that the solder is really making good connection throughout. Now I'm going to reheat that just a little bit, and I'm going to wiggle it and do something that is not good. So I was moving that wire while the solder was cooling, and that makes for a poor connection. Oftentimes it's a cold solder joint, as we say. And if you look carefully, you can see that the first connection that we did that I did properly is nice and shiny. The next one here is slightly dull, and if I wiggle it a little bit, it comes right off. That is not a good thing, and that indicates that the solder has not evenly flowed throughout the connection. Thus, not only is the connection physically weaker, but it could lead to increased resistance. You want a zero resistance when you're soldering wires together or wire to a terminal. But in this case here, it could also be an open, and you would not spot it. So let's make that connection hot again from the back side. Get a dab of fresh solder on my soldering iron tip, and I will solder it together like that. All the solder is nicely flowed. Let it cool off for a second, and we'll see a nice shiny connection again, as it should be. Then ultimately these two wires would plug into a circuit board or some other circuit that requires a volume control such as this. The next project that we're going to get into as far as demonstrating is going to be a very common one, that of assembling components into a circuit board. I'm not as much going to describe a lot of theory about the specific circuit. We're just going to insert some components right now. Oftentimes components such as a capacitor, like this, comes with the leads that are preformed to the right size. And if the circuit board designer is good or approaching good, what we do is they ensure that the component will fit down inside of the circuit board like this. When doing this, once the leads are inserted, you would bend them over slightly in order to keep the component in so it doesn't shake out. And now we're going to actually do some soldering of the circuit board. I'll try to zoom in on this one. There we go. So hopefully you'll be able to see some of the principles for attaching a component to a circuit board. Once again, I take my soldering iron. I make sure I wipe it in the brass to take off any of the corrosion and other such material, and then I apply fresh solder to the tip of the soldering iron. I'm going to come down and I'm going to hold with one finger, the circuit board, and I'm going to apply heat to one side of the component going through that hole. Then I'm going to dab some solder in there, let it set for a minute to make sure that the solder is nicely flowed. I'll do the same to the other side, and then we'll see what it looks like. So here we see the component. Hopefully this is going to be viewable. So here we see that I'm going to use a pointer for to illustrate. You see the solder is flowed over the junction in a nice smooth shiny silver type of flow between the actual pads and the component. That's a sign of a good solder joint. The other side just has some extra solder, and that's okay. I can leave that there. But that too has a nice even flow all around the pad up to the component that's protruding from it. We'll take our side cutters and right flush with the board, nip off that wire. Make sure the nipped wire doesn't go into your face. I'm wearing eye protection right now. And actually, I'm wearing magnifying glasses, which is sometimes a challenge when looking through the camera of a lens at the same time. lens of a camera. So here are the glasses, the eye glasses that I'm using. Tough to see here, but this is a head. It goes on my head, and it offers nice magnification such that I can look almost as to a better. There we go. To a better view than even you're able to see here on this. So that's one component on here. We'll add another component. But while I'm thinking about it, if we kind of zoom out a little bit, you will see that I have control of some lighting here. I have a really cool light, a couple of LED lights on gooseneck. It's a fabulous tool, and I'm able to get good lighting where on the work surface that I have. That plus the now that we're zoomed back, plus the head magnifier is I'm able to see up close and see indeed that I have a good solder joint. Okay, let's next put in a transistor. This, and remember I'm grounded, this pad is grounded, my hands are always in contact with the pad. Oftentimes there are wristbands that you should use and clip to this to make sure your whole body is at the same potential. That makes for a good anti-static type of assembly operation. Here's a transistor. It may be difficult to see, but the leads are you see 3 leads, and the orientation of the package tells me how to insert it into the circuit board right over here. There's a rounded part of the silk screen there for Q. What does it say? It's for Q2, I think. And I'll insert it right like this, and then once again bend over the leads in order to make sure that the component is going to stay in place. Let me zoom in again, and we'll see that as I solder it. Okay, here we are, about ready to solder this transistor that I've inserted into the circuit board. And you see how it goes through the circuit board, and I bent over the leads in order to ensure that and we're ready to solder. So let's take the soldering iron right here, wipe off the tip, keep it nice and clean, add some fresh solder. And now I'm going to go in and I'm going to solder those joints that the pads that we just inserted the transistor to. So I'm going to hold the board firmly with one finger. Then I'm going to heat a pad and apply solder. Heat a pad and apply solder. Heat the third pad and apply solder. Now this has a heavier pad to it, so it required a little bit more heat, because the larger copper surfaces tend to suck away the heat a little bit more. And you can see that these are good solder junctions. I have indeed, there's a little piece of solder goober over there, and 3 good joints, as I've explained before. Let me do something that is common. That's a common mistake that is to apply too much solder. So what I'll do is try to get the light to show it just right. I'm going to apply too much solder and see how, if I apply too much solder, there may be a blob. I may have shorted across, inadvertently, I may have shorted across this, the connection there, and that's not good. Obviously, you want to correct that. To make it clearer, what I'll do is I'll snip off the leads, and it is obvious that we have 2 leads that are soldered together, and they shouldn't be. You want to be aware that pads sometimes are connected by traces, but in this case these were 3 distinct pads. So what I'll do is, first of all, I'll just try to clean that up by cleaning the tip of my iron. And then I'm going to go right here and heat up, and the natural flow of the solder will be toward the soldering iron. I'll clean that, I'll wipe that off, and I'll do it again. And there I have corrected that, that connection where there was too much solder. I didn't mention along the way that there is a cool, this brand is called Easy Braid. It's often called solder wick. And what it does, it's braid, copper braid with flux in there, and it makes for a nice desoldering or taking off. See how a nice solder goes onto there? So what I can do is make sure my soldering iron and my soldering tip is nice and clean. What I can do is go in and use the braid to suck off or wick off excess solder. I do that by heating the braid and put it in next to the junctions, and voila, I have nice, clean, minimal solder. In fact, I have removed so much solder that I can nip off further of the leads. Be sure not to take off too much solder, but you can tell by the view of the quality of the pad that things are soldered just right. I normally put my components a little bit lower onto the circuit board just by pushing the components in this case for demonstration. I'm not. The last thing I'm going to demonstrate for this board, before I finish it up in a real quick manner and show you the results, is the integrated circuit. Now here is an integrated circuit. Remember, I am grounded. We're all at the same potential, so there's no chance for electrostatic damage to the circuit. This happens to be, if I can read it here, I can't. It's a controller. I think it's a PIC. Yes, it's a 12F629 from Microchip. So it's a microcontroller, and what we're going to do is insert it in its position on the circuit board. The dot for the circuit, for the IC itself, or it is oriented at pin 1 in that manner here, or the little notch at the top of the circuit. And after I squeeze the leads together a little bit to get them in the circuit, into the circuit board, and I'll bend over opposite leads, and it's in place. So now it's an easy matter to see the circuit board, and hopefully the focus will stay with us. Taking my solder, my wiped off clean pencil tip, holding the board with my one finger, and then going on each of the 1, 2, 3, 4, 5, each of the 10 pins in succession to solder them. Sometimes the board's a little small. So there's one, not that one. There we go. Hopefully you can see this. Yeah. I'm balancing my fingers with the view of the camera. And here we go. There's 1, 2. Notice how I hold the soldering iron on the joint a little longer. So I apply the heat, apply the solder, and remove the heat. So I'll do it to the other 5 as well. Apply the iron, which applies the heat, apply the solder, remove. So now we take a look, and I see that I didn't do a good job on these two pins right here. So I'm going to do those again. and this one as well. And this one as well. Okay. Now, I feel really good, I think, about these solder joints here. And I think that I'll take the next moments off camera to assemble the board, and I'll come back and I'll show you the completed project, hopefully, with an operational key and speaker. So if I happen not to do that because of one reason or another, this is the conclusion of the soldering demo, along with Bobbie Williams for the University of Tennessee's Amateur Radio Club. Thank you very much for watching, and back to Bobbie.